In just 12 minutes, let's dive in and learn how to integrate Particle's Smart Wallet as a Service within applications built on Base. Base fundamentally represents a true belief in an open source, free to use, and globally available on-chain ecosystem. Specifically, Base outlines a few key phases to achieve this goal of an open financial system built upon various different on-chain apps. This starts with protocol development, then exchanges like Coinbase, and then of course, probably most importantly, as well as where we fit in, Base believes that one of the key components to unlocking mass adoption is through a mass market interface for digital currency apps, basically enabling consumers and businesses a central interface for interacting with Web3. Once this is achieved, which it has been in a large capacity, then Base believes that the final phase, phase 4, to reach this ultimate goal of 1 billion users is to build the actual on-chain apps to create an open financial system. Although, like I mentioned, where we tend to fit in is within this phase 3 of building a mass market interface, a method of working with Web3 that's accessible to consumers, to general people. This is exactly what we aim to achieve with our Smart Wallet as a Service, facilitating account creation and application interaction through social login, and of course by using smart accounts. So with the usage of Smart Wallet as a Service, we can implement a simple 2-click onboarding process while retaining almost infinite flexibility through the utilization of account abstraction. Because of this fundamental alignment with what we aim to achieve within the ecosystem, we are quite excited to support Base as one of our foundational chains supported by account abstraction, which brings me to the video today. In just 12 minutes, we're going to build a demo application that connects to Base Goerli, facilitates onboarding through Google or Twitter, and then sends a sample user operation all natively through Particle's Smart Wallet as a Service. So let's jump right into it. So like I mentioned, we're going to be building a pretty simple application. The goal of this will be to showcase utilization of both Particle's Auth Core SDK hand in hand with our account abstraction SDK. And of course, using this directly with Base Goerli. So we'll onboard a user, assign them a smart account, and then simply send a user operation. So let's go ahead and get started. To begin, we're actually going to work on our index.tsx file. We'll head over to the main app file in a moment. Within our index file, let's start by importing a few different Base libraries. So let's go ahead and get started with React. We can also import React DOM, and then we'll need a few different objects from our Particle Network libraries, starting with auth type, which will be from @particle-network/auth core. Then we can also import Base Goerli from @particle-network/chains. And we'll also need to import both auth core context provider and optionally prompt setting type, which will come from @particle-network/auth core modal. Then we can close this off here by importing our app component from app. Okay, perfect. So now we'll need to render our application, but specifically wrap our main app component with an auth core context provider, which we'll be using to configure Particle's Smart Wallet as a Service. So to do that, we can call React DOM.create root, then pass in document.get element by ID, which will take root. Then we can do that as type HTML element and then call .render. We can wrap this in React.strict mode. And then in here, let's open up auth core context provider. Within auth core context provider, we can go ahead and configure the Particle Auth Core SDK. Let's do that by opening up options. And of course in here, we'll need to pass in a few main parameters to set up Particle Auth. Although before we do that, let's head over to the Particle dashboard, as we'll need 3 main values: our project ID, our client key, and our app ID before we can get started here. So let's head over there and grab those values. Okay, so as you can see, I'm now in the Particle dashboard. I can go ahead and click add new project. I'll name this Base Demo and click save. Then in here, as you can see, I'm now in the dashboard. We have all of the main components of the Particle Network tech stack, our paymaster, our bundler, even customization for Particle Auth. But for now, let's stick to just setting up our application and of course retrieving the project ID, client key, and the app ID. We'll need to select the type of application that we're going to be making. I'm creating a web app, so I'll select web. I will name this yet again Base Demo, and I'll go ahead and throw in the domain in which I'm hosting this application right here. This is actually optional. If you're creating this on localhost and have yet to actually deploy the application, then don't worry about this. You can just throw in a placeholder domain and it'll still work perfectly. But in my case, I'll be hosting this on particle-base-demo.replit.app, so I'll go ahead and leave that there and then click OK. So with that done, let's go ahead and copy our project ID, our client key, and our app ID. Then we can go ahead and throw those into environment variables in our application and continue. So now that we have those set, let's start by defining the project ID. In my case, this will be process.env.react app project ID. Then of course I can do the same thing for client key as well as for app ID. Let's move on to our more general configurations. We can start by defining the different auth types. This is an optional field, but in my case, I want to restrict the authentication types of the Particle modal to just email, Google, and Twitter. Although we support a ton of different types, in my case, I'll be restricting it to just these 3. So I can pass in auth type.email, auth type.google, and auth type.twitter. I'll also want to set this two dark modes. So I can do theme type as dark. I'm going to set my fiat coin to USD. It'll already be USD by default, but if you'd like to change this to another currency, then you can do so within this field. Same thing for language. And I'll also need to set a field here called ERC457. This will dictate what type of account is shown within the wallet modal. This application will be using a SimpleAccount implementation. So we can set the name to simple and the version to 1.0.0. Then we can close this off here by defining wallet, which will be an object. Within here, we can select visible to true. This just means that the wallet will pop up whenever you log in. So we'll have a little wallet modal pop up on the bottom right-hand side of the screen by default. Then additionally within here, we can select custom style, which in my case, I just want to restrict the specific chains supported by the wallet to Base Goerli. And then finally, we can pass in app and immediately close it off there. So there we go. That's all we need to do with an index. We're using Auth Core context provider along with their application component so that we can define specific configurations within Particle's wallet as a service. Move on to app.tsx. This will be the file containing all of our main application logic, including all of our buttons and even our JSX. Within app.tsx, let's start by defining again a few different base libraries that we'll be using within the application. We can start with React and of course use state and use effect. We can also import a few different React hooks. This will be use Ethereum, use Connect, and use Auth Core from @particle-network/auth core modal. Again, we can also import Base Goerli from @particle-network/chains. Then for the account abstraction functionality, we can import a wrap provider and SimpleAccount from @particle-network/AA. Now we can simply just import ethers as well as optionally notification from AND. Then we can close this off here by throwing in our CSS. Okay, so that's all of our base libraries. Let's move on to defining our main app component. We can just call this app. To start, we can define our different hooks, which first will be provider as use Ethereum, then connect and disconnect as use connect, as well as user info with use Auth Core. We can also go ahead and set up a quick state of balance and set balance equal to use state. Now, before we start creating our different buttons, we'll need to actually create our smart account. So basically tell our account abstraction SDK what type of smart account we want to use on Base Goerli. So we do this in a variable called smart account and set that equal to new smart account. We can of course pass in provider. And here in the body, we can go ahead and pass in project ID, which similar to index will be process.env.react app project ID. Same thing with client key and app ID. Then just simply within here, we can open up AA options in which we can choose what smart account implementation we want to use within our application. We actually support Base on all of our different implementations: Biconomy, CyberConnect, and SimpleAccount. So in here, you can say either Biconomy, Simple, or CyberConnect, and all three will function with Base. In my case, I'll be using SimpleAccount, so I can select Simple. And within here, I can define the chain ID that I'll be using the smart account on. In this case, that'll be Base Goerli.id. And I can also pass in the version of the smart account, which will be 1.0.0. With Biconomy, you can use 2.0, but in our case, we're just sticking to version 1, which is the only version currently supported by SimpleAccount. Okay, so now with that set up, let's quickly define a custom ethers provider so that we can send normal ethers transactions and actually have them be routed as user operations. We can name this custom provider and set that equal to new ethers.providers.web3 provider. Then we can pass a new AA wrap provider, which will take smart account, and then we can close this off with any. Basically what we're doing here is using our custom account abstraction provider to enable utilization of the smart account natively on ethers. Okay, so now we can move on to creating our main application. Let's start with the logic for keeping our balance updated within the front end. We can start that off by opening up a use effect, and within here, we can conditionally call a function based upon if user info returns a truthy or falsy value, meaning if a user is logged in or not. If it returns a truthy value, meaning a user has been logged in, then we can call fetch balance, which I'll define in a moment. And then this will be dependent upon the state of user info. So now let's go ahead and actually define fetch balance, just as we typed it out there, which will be fetch balance. Within this function, we're basically just going to retrieve the balance of the smart account's public address. So let's start by defining balance response, and that'll be await custom provider get balance, which in itself will take await smart account get address. So we're retrieving the address of the smart account, then passing in the result of that into the get balance method on ethers. Finally, we can update the balance state with set balance, and then formatting the balance with ethers.utils.format ether, and passing in balance response. So now let's create the latter two functions of our application. This will be handle login and execute user operation. Handle login will basically handle all of our social login functionality, enabling users to use the application through their Google or Twitter account. So let's name this handle login, and this will take one parameter called auth type. And then within here, we can basically check if a user is logged in or not by, of course, the status of user info, which in this case, we're checking if it's not true. So if user info actually returns a falsy value, meaning that user is not logged in, then we'll continue on to calling the login function right here, which in this case will just be await connect, and then social type as auth type, and the chain as base Goerli. Okay, and the final function to go over is execute user op. Essentially what this will do is send a sample transaction, in this case 0.001 ETH, to a dead address on Base Goerli. So let's name this execute user op. To start, we'll have to retrieve the signer object. We can name this signer, and that'll be retrieved from custom provider.getSigner. Then after that, we can go ahead and construct a transaction object called tx. And this will be relatively simple, just two different fields, first of which being 2, which we can just set to this dead address right here, and the second being the value, which we can format with ethers.utils.parseEther, and in my case will be 0.001 ETH. Then we can go ahead and send the transaction in a variable called txResponse, which we can just simply do with await signer.send transaction, then passing in tx. Then once that transaction has been sent, we can wait for the transaction, something called txReceipt, which will just be await txResponse.wait. This will wait before the transaction is settled, and we can return a completed transaction hash. And then of course we can close this out just by doing notification.success. Then as the message, we can throw in txReceipt.transaction hash. This will basically just throw a pop-up onto the screen containing the transaction hash of our sample user operation. And that's it. Let's now go ahead and structure all of this and map it at the front end within our JSX. Typically, I skip this as it's a little bit repetitive, so I'll go ahead and get this finished and then come back. Okay, so as you can see, it's pretty simple. We're basically just checking again if user info is defined or not. If it isn't, which means a user isn't logged in, then we display the two social login buttons that we have here, which is sign in with Google or sign in with Twitter. Alternatively, if a user is logged in, then we can go ahead and display their name, their balance in ETH, as well as the execute user operation button alongside a disconnect button, which calls the disconnect function derived from useConnect. Okay, so now all we have left to do is throw in export, default, and then app. And we're done. Let's go ahead and run it and see if it works. And there we go. Looks like it worked. We have the Particle logo and the Base logo here, right above our sign in with Google and sign in with Twitter buttons. Let's give it a try by signing in with Google. Within the same web page, I have all my Google accounts here, so I can go ahead and select this one. And now I'm logged in. We have my balance in ETH on Base Goerli at the moment. That's 0.02. And of course, we also have the Particle wallet pop up, which is my simple account on Base Goerli. But let's go ahead and give this a try by executing a user operation with this button that we created right here. And as you can see, we have this pop-up right here. I'll go ahead and click on confirm. And there we go. There's our transaction hash. Let's go ahead and copy this and then head over to the Explorer and check it out. And here you go. About 21 seconds ago, we have 0.001 ETH from my address right here to the dead address that we defined in our code. We're very glad to be supporting Base natively within our Smart WaaS as a service, allowing builders creating applications on Base to facilitate truly seamless, flexible onboarding into smart accounts. And this, of course, getting us one step closer to achieving this goal of 1 billion users. If you'd like to learn more about Particle Smart WaaS as a service, then I'll have a short video about that linked below. If you'd like to give our web demo a try or the demo that we created today a try, then I'll also have those linked below.